We've been combining like terms with whole numbers the past few lessons. Today we're continuing to simplify expressions but with rational numbers. So the process remains the same, but we do need to review how to combine fractions with addition and subtraction. So let's look at this problem. Write the expression in standard form by collecting like terms. Okay, so I see 2/5 g minus 1/6 minus g plus 3/10 g minus 4/5. So I'm just going to zoom in here because we're about to circle and box like terms. So I see that this variable g is present here with the 2/5, is present here with the minus g, and the plus 3/10 g. Remember, we take the sign in front of the number because that's going to play as a negative and a positive when we start combining them. I also see a minus 1/6 and a minus 4/5. So now we can go ahead and start combining like terms with the circles and then the squares. So I'm just going to write them over to the side here. 2/5 g minus g plus 3/10 g. Okay, so before we start, oops, I forgot the G on this one. So before we start combining like terms, we need to think about what variable would come in front of the G. Well, I know that there's physically one G there. So I know that represents one whole as the variable. I'm sorry, as the coefficient in front of the variable. So if I'm going to start solving from left to right, let's go ahead and think about how can we take away 1G from 2/5. Well, let's first rewrite one whole into a fraction with a denominator of 5. So if we're going to have a denominator of 5, that means the numerator also has to be 5. So 2/5 g minus 5 over 5g. We'll deal with the 3/10 in just a second. Okay, so now that I have this subtraction problem written out, how can we rewrite subtraction problems? Well, we know we can always change it to adding the opposite using KCF. So I'm going to do that here. We're going to keep the 2/5 g. We're going to change the minus to a plus, and this positive 5/5 now becomes a negative 5/5. Okay, so looking at my tic-tac-toe chart, this is probably way too big. We're going to look for a positive combined with a negative is telling us that we need to subtract them. So I'm going to rewrite that over here. 5/5 minus 2/5. Well, I know that we subtract the numerators up at the top and leave the denominator the same. So 5 minus 2 is 3. The denominator of 5 stays the same, and the variable also stays the same. Well, which fraction is bigger, 2/5 or 5/5? Well, it is 5/5, which means our answer is a negative 3/5 g. Okay, let me actually move that over so I can get ready to write what we have left. So we've combined the 2/5 g minus the 1g, and now we still have to add 3/10 g. Okay, so how do we combine that? Well, we know we can't combine fractions unless they have common denominators. So what denominators do I have? Well, I see that I have a 5 and I have a 10. So we need to think about what can we do to these fractions so that the denominators are the same. I can't simplify the 10 to get a 5, but can I get 5 to become a 10? Yes. I just need to multiply by 2. Okay, so what I do to the denominator, I also need to do to the numerator. So if I take negative 3/5 g over here, and I multiply it by 2 on the bottom to get 10, I have to do the same thing to the top. And so I know I multiply across. 3 times 2 is 6. 5 times 2 is 10. We still have a negative being multiplied with a positive, so that means we have a negative answer. And so we have negative 6/10 g plus 3/10 g. Now, can we combine them now that they have the same denominator? Yes. We also still see that we need to subtract because the positive and negative signs are different. So we are going to subtract the numerators. 6 minus 3 is 3. And we're going to leave our denominators. And what number is bigger, 6/10 or 3/10? 6/10 is bigger. So our final answer is negative 3/10 g. Okay, we have finally combined all the g's together. And now we need to go back and look at the parts in blue. So I see that we still need to combine -1/6 minus 4/5. Well, how can we rewrite subtraction problems? I know we can change them to addition problems by adding the opposite using KCF. So I have changed the plus, and the 4/5 has now become a negative. Now that we have the signs that are the same, I see that we can add them and keep the sign. But I also know that our fractions do not have the same denominator. So I see that there's a 6 and there's a 5. So how can we have those have the common denominator? I know I can't make a 6 a 5 or a 5 a 6. Well, the easiest strategy is to multiply it by the opposite number. So in other words, I would multiply the fraction with the denominator of 5 by 6 over 6, and the fraction with the denominator of 6 by 5 over 5. So let's see what that looks like. So -1/6 times 5 over 5 gives us a -5 over 30, and a -4/5 times 6 over 6 gives us a -24 over 30. So now we have common denominators, so let's just rewrite -5 over 30 plus a -24 over 30. And we said that we can add them and keep the sign. We add with our with our numerators. That would be a -29. And the denominators stay the same. So we would put our -29 over 30. We could write that as a minus 29 over 30. Can we combine anything else? No. Then this is as simplified as possible. So there was a lot that went on. The first thing is continuing to combine like terms. So circling things that are in common, boxing things that are also in common. Using our KCF, whenever we see subtraction, we can always rewrite it to addition. Using our tic-tac-toe chart to remind ourselves of the rule when we are adding integers or when we are multiplying or dividing integers. And then also double checking to see if there's anything else to combine at the very end. So let's go try simplifying another expression with fractions.